So we're going to do our same method. We still are investigating the same question, convergence or divergence. Does the series converge or diverge? And the first thing we're going to do is look at the terms of the series. Now, notice when we look at the terms of the series, actually, that we can use partial fraction decomposition. So the terms, we know that a sub n is 1 over n times n plus 1. But we can rewrite that using partial fraction decomposition as, let's see, looks like it'll be minus, actually. Okay, so we've actually got, let me see here. Let me try to write this a little better. So a sub n is equal to 1 over n times n plus 1. But that's also equal to 1 over n minus 1 over n plus 1. Okay. So let's go ahead and start. Now, we're told down here that n starts at 1. So we'll start off a1 is going to be 1 over 1 minus 1 over 2. It is helpful to use the decomposition as opposed to the original formulation for a sub n. So that's why you'll see me doing this. A sub 2 is going to be 1 over 2 minus 1 over 3. A sub 3 is going to be 1 over 3 minus 1 over 2. A sub 4 is 1 over 4 minus 1 over 3. And dot, dot, dot. A sub n, 1 over n minus 1 over n plus 1. Ooh, I've been making errors. So let me clean this up. 1 over 3 minus 1 over 4, 1 over 4 minus 1 over 5. Okay, now partial sums. Let's look at the partial sums. Now remember, the partial sums formula is going to be the S sub n is equal to the sum of a1 plus a2 all the way up to a sub n. And let's see here, so s sub 1 is just going to be a sub 1. So it's just going to be 1 over 1 minus 1 over 2. S sub 2 is a1 plus a2. So we'll get 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. Now for S3, we'll have a1 plus a2 plus a3. So we'll have 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4. Okay, and then for S4, as we said before, that's just going to be S3 plus A4. So we'll have 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5. And then for Sn, which would just be the sum of AK, k equals 1 to n, we'll get 1 over 1 minus 1 over 2 plus dot 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 plus 1 over n minus 1 over n plus 1. Now let's see if we can find a pattern. So here we'll have, for S1, we will have, there's nothing we can do. We've just got 1 over 1 minus 1 over 2. For S2, notice that some terms are canceling out. So we've got minus 1/2 and plus 1/2. So we're left with 1 over 1 minus 1 over 3. The same thing is going to happen for S3. Minus 1/2 is going to cancel out with plus 1/2. Minus 1/3 is going to cancel out with plus 1/3. So we're left with 1 over 1 minus 1 over 4. Same thing is going to happen with S4. These middle terms or these inner terms are going to cancel out, and we'll have 1 over 1 minus 1 over 5. Now, it's time to guess a pattern. what do we think the pattern is for Sn? Because we can't just leave it with dot, dot, dot. It's hard to take a limit with dot, dot, dot. But looking over here, we can see a pattern. The pattern is Sn should be 1 over 1, because each term starts with 1 over 1, minus, each term has a minus, and then a fraction. And what is the fraction? The numerator is going to be 1. The denominator is going to be n plus 1. Okay. And so now we can look at the limit of the partial sums and say the limit as n goes to infinity of Sn is the limit as n goes to infinity 1 over 1 minus 1 over n plus 1, which is equal to the limit n goes to infinity. Oh, that limit's just going to be equal to 1, right? Because this term is going to go to 0. So this limit is just equal to 1. So we say, what is our conclusion? Our conclusion is that our series from 1 to infinity, 1 over n times n plus 1, converges, and it converges to 1, right? So in determining whether it converged, we actually were able to compute the limit. So the sum is 1. And another way that we might write this would be to say sum from 1 to infinity, 1 over n times n plus 1 equals 1. So this is yet another way to write 1. So we can write 1 so many different ways. I kind of want to point out, this is the last thing I want to point out in this video. Notice that I did not write n equals 1 to infinity, right? I didn't write n equals 1 to infinity. The reason why I didn't do that is because it's understood, right? So if nothing is written, if there's no indication down here, that means that whatever is the index that you're using in your term, that is the index that you're going to be counting with, okay? So I will frequently leave off n equals 1 or k equals. I'll leave off n equals or k equals and just write my starting point and my ending point. Thank you.